welcome you to my presentation. I am talking about the technology highlights in Geodeck 2024, and there are so many highlights that I can mention every one of them only briefly, and there are even many more than you find in that presentation. So if you have questions on one of the topics I talk about, or if you want to know more in a certain area, please feel free to ask us late after the talk or write us an email and talk to our experts. So today everyone is here, so you have the chance to talk to all our experts in different topics. Perfect. Okay, so I already done with the first slide and go to the next. So before I start with the real presentation of the highlights, I want to introduce myself. Matthias already started with my name, so I can skip that. I studied mechanical engineering at the University of Kaiserslautern, and I also did my PhD in Kaiserslautern at the Institute for Composite Materials. And in 2019, I joined Mass2Market as a business manager for digital material R&D, and since 2023, I am deputy team leader of business development. In this talk, I will talk about improvements of different application areas. But first, I would like to start with general improvements that will boost the work efficiency of all Geodeck users, not only in the certain areas. So with the new Geodeck 2024 release, it is very easy to run a Geodeck simulation in the job queue. The jobs run in this queue in the background on your local computer or on a compute server. You can just start a bunch of jobs and collect them when they are all finished. You can run them throughout the night, over the weekend, during the workday, whenever it suits you. And this feature will help you to smoothly integrate Geodeck in your existing workflows and save your precious time and resources. And as you're used from us, it is easily accessible in the user interface. Okay, talking about the user interface. Another improvement is the new help button in many dialogues. We try to make it easier to access the Geodeck help, and the help button will directly link you to the related pages of the user guide with the general description of the feature and also specific description of all relevant parameters. So no browsing and searching in the user guide anymore, unless you enjoy the good read. And there's another update of the user interface. We have been redesigning it over the last few years in a way that a user can easily access the required information or hide what one does not want to see. With Geodeck 2024, it is now possible to minimize the view controls at the top of the user interface. So you can maximize the space to visualize the loaded data. And all the mentioned user interface elements on this slide can be collapsed, they can be opened, they can be tracked from the main interface to a different screen, wherever you want them to be. So, and there's another very important kind of visualization, and that's the visualization of your results. For us, it has always been very important to enable the user to generate impressive images and videos of their models and results. We want you to enable you to promote your research so that it stands out, not only scientifically, but also because your slides and publications simply look good. And in Geodeck 2024, geometries in 3D can be visualized with shadows, which makes it easier to see what's in front or in the back of a microstructure. And the shadows may be combined with all the other camera options, like global lighting, as you can see on this slide. And now we take the first step into the Geodeck workflow and look at the highlights in image processing and image analysis, which are important for all applications. With Geodeck 2023, a GeoApp was added to automatically create a digital twin of a granular geometry based on a 3D image of a real material. And this GeoApp computes properties like the solid size and the property size distribution on the real image and the geometry model and minimizes the error between the two to get a good match. In Geodeck 2024, we improved this GeoApp to create a 3D digital twin based only on a 2D image. Because in general, 2D images are much easier to get and they are cheaper. So you only need an SEM image or maybe a cross-section, a micrograph, and maybe you can even do those in your own lab and you do not have to send out the specimens to another lab where they can do a CT scan or a FIBSEM. But we still deliver the same quality of structures that you are used from Geodeck. So here this technology is shown for an SEM image of a solid oxide fuel cell cathode, where the original image is shown on the left and the created digital twin is shown on the right. And visually, these two geometries look very much alike, and the size distributions of the two material phases are also very close. So you get a really good digital twin only based on the 2D image. And there are more impressive features in image analysis. In Geodik 2024, the AI segmentation is even more efficient. You can turn on the magic quad feature, which I think is really cool, that utilizes powerful algorithms that help you to distinguish labels at the boundaries of different phases. You can see that here in this video. And so the precise labeling of your structure has never been easier than with this feature. Moreover, you can have multi-channel images, so you can import information from different detectors, for example, and combine them to get the best result on your segmentation possible. And you can also import crystal orientations from EBSD devices. So now we go one step down the line from the segmentation to modeling. As you know, in Geodik, we have very powerful structure generators, and they create models of many materials. And our aim is not to only provide those in Geodik, but also make them available outside of Geodik. And sometimes you might want to run a specific simulation which is not available in Geodik, but want to use one of our geometry models, and then you need to export them, for example, to COMSOL or ANSYS. And one way to export such a high-quality surface mesh is geometry is making a surface mesh. And when you export surface meshes to an FE code, you have to be aware that there may not be too many elements. If you have an excessive amount of elements, the FE simulation gets really slow. So we have coarsening, smoothing, and remeshing to reduce the number of triangles. And in Geodik 2024, the remeshing becomes even more powerful because it allows adaptive remeshing. That means that the size of the triangles is adjusted to the size of the feature which is meshed. And on the right, you can see a cathode geometry which has been meshed with 500,000 triangles and was exported to COMSOL. So after these general informations, let's move to the more industry-specific ones, but still watch out. Even if you are not developing batteries or fuel cells, there will be something interesting for you too. And this first new development is, again, all about efficiency. We added a new object type to GrainGeo, which is called agglomerates. And you can use those agglomerates, for example, to model catalyst layers of fuel cells, which consist of carbon particle agglomerates. And you can also use them, for example, to model carbon black in a polymer. And before this, you could do this with GrainGeo. Before, you had to generate these agglomerates manually. It may take you a few days. In Geodik 2024, it only takes minutes because, as I said, we added this new object type to GrainGeo. So you can, in the GrainGeo user interface, choose this sphere agglomerate object type. There are 3 different ones, to be precise. There are branch-like agglomerates, there are sphere-like agglomerates, and there's something in between, which we call intermediate. And then you can create the structure in GrainGeo as you are used to with other object types and get real quick structure of your geometry. So, and as the structure generation can be made easier when you have the right object type, the simulations are made easier and faster if you use the right simulation model. So it's important to consider the specific questions you have in your material development, and in Geodik you can then choose different models when you develop your battery that answer those questions. There is a homogenized model, the best meso, and a fully resolved model, the best micro, at which we now look in detail. And the best micro performs a very accurate battery charging simulation on the large microstructure. It gives you a very detailed insight into the process in the batteries, such as the local ion concentration while charging. But it can be time and memory consuming, even if with the optimized Geodik solvers. So there's the homogenized simulation with best meso that solves a 1D problem to predict the charging or discharging behavior of a battery or half cell, but it does not provide detailed results on the micro scale like the full model. The advantage, it's really fast. And the parameters for the homogenized model are computed automatically in Geodik. So use the best micro sophisticated models if you need them. But if you want to do a parameter study, just take the best meso. When you look at the plot on the right, you can see that the results are almost the same. But if you look at the table on the bottom, you see that the runtimes definitely are not. So we will dive even deeper into battery simulation, but have a look at the bigger picture first. So maybe you thought about buying an electrical car, or the lucky ones of you already have one. And now imagine you could charge that car only 500 times. And that does not sound too appealing. So what luck that in Geodict we can help you to understand and tackle the degradation and the aging of battery cells. There are several degradation mechanisms leading to battery aging. One of them is mechanical degradation, which occurs because the expansion of the active material due to the intercalation with lithium. So correspondingly, during the delithification, the active material shrinks again. And that, of course, causes mechanical loads in the active material. In Geodict 2023, we introduced the coupling of electrical chemical simulations and the mechanical simulations in a module called BatteryDict Degradation. And in 2024, we further improved this feature and updated the pre- and post-processing of the mechanical degradation. Another mechanism is lithium plating, and that also leads to battery degradation. It can occur in the anode, especially at high charge rates or low operational temperatures. And with the Microsoft model, you can compute and output the potential versus lithium field. And this is shown here for the charging of a battery at 3C, where the voltage is below 0, and the risk of lithium plating is largest toward the separator. So you can use Geodict to optimize your microstructure to reduce the risk of lithium plating. And one important measure, apart from preventing the degradation mechanisms to extend the lifetime of your battery, is optimized charging, so pulse charging. And this can now be simulated in Geodict, as we included a relaxation step, which is crucial for pulse charging. This relaxation step, or in this relaxation step, the concentration gradients of lithium ions decrease, and a steady transport and exchange of lithium ions is enabled. And that decreases the lithium plating and thereby extends the battery lifetime. And in addition, faster charging is possible. So here you can see how easily you can add this relaxation step to your simulation in the BatteryDict user interface. You just can choose it here and also add a time. So now we look at this example of the relaxation of a NMC LCO cathode. During the dilithiation with 2C charge rate, the concentration gradients evolve in the electrode. And this simulation returns the cell potential over time, as you can see on the left-hand side. During the relaxation, the cell potential relaxes towards the open circuit voltage. You can see that in the curve. And the concentration gradients in the electrode disappear. In the left structure, you can see the visualization of the concentration gradients, and in the right structure, you can see the visualization of the relaxation currents. So now we move from batteries to nonwovens and foams. And those are materials that we regularly encounter in our daily life. They are in hygiene products such as paper tissues, they are in filters, they are in metal products, like in the face masks we now all know. And they are also, for example, in the insulation in our attic at home. In Geodict, we have powerful methods using artificial intelligence to support you with the development of nonwovens for your products. And in 2024 version, there are several enhancements. We now support more than 1 GPU for your AI applications. And then we have a newly trained neural network that we ship with FiberFind AI. And with this, we can now do even more complex analysis of things such as the determination of a fiber length distribution. The new neural network in FiberFind is more robust regarding fiber shape and fiber orientation. So you can have fibers in any direction in your model, and you can also have circular and elliptical fibers. And the diameter range is bigger, from 4 to 26 voxels. And you can also have a varying diameter per fiber, so your fibers can have different diameters, and the diameter can even change along the length of the fiber. And on the right, you can see a comparison of experimental fiber length distribution and the simulated fiber length distribution in FiberFind. This data was measured in the lab within a research project called DigiLaugB. And here you can see that the measured fiber length and the fiber length determined with FiberFind match really well. So this shows that you can predict the fiber length distribution with FiberFind for such a material. The material is a glass fiber reinforced thermoplastic that has been injection molded, so the fibers are short enough that they are all within the domain of the of the simulation. So when you now have all this data from FiberFind on your material, of course, you want to do something with it. So what you can do now is you can generate digital twin based on these results. And this digital twin gives you the opportunity to change parameters and run parameter studies and develop your next material, your next nonwoven, your next composite. And how you can do that, we have now the Generate Nonwovens app. And this app takes the results from FiberFind and then generates a FiberGeo model based on those FiberFind results, and then optimizes the FiberGeo model until the model and the scan match. And you can see that here in the example of a nonwoven. On the left side is the scan, and on the right side is the digital twin. And first, they really look very much alike, and also parameters such as the fiber curvature and also the Z permeability match really, really well. I said nonwovens and foams, so here come the foams. And for foams and nonwovens, viscoelastic material behavior is really interesting because you do not want to only look at the steady loading, but at things like damping properties, resetting behavior. That's important for example, shoes or mattresses, wherever you need the material to reset again after loading. And in Geodik 2024, this viscoelastic material model was included in the FEMA solver, which is part of ElastoDict, and there's the generalized Maxwell model implemented. So you can see, and as you can see in this video, you do not only have the loading, but also the unloading, and you get the Getter hysteresis curve now from Geodik. So you can now use this model, also thanks to our colleagues at Fraunhofer ITWM, easily in the user interface of ElastoDict and simulate your materials. Then we move to the next topic, digital rock physics. In digital rock physics, the relative permeability is a really important parameter. But the reservoir engineers expect a smooth curve as the curves when they are fitted from an experiment. So we could, in the past, predict the relative permeability with Geodik, but the curves look somehow like the curves on the left, a bit not as expected. And in Geodik 2024, we have the LET fit. If you want to know why it's called LET fit, look at the names in the publication on the bottom. And this LET fit returns the curve just as your reservoirs engineers expect them. So it will be a lot easier for you to incorporate Geodik into your existing workflows to replace experiments or to add to already existing experiments, because the curves just look as they are expected and people will accept it as a valuable input. And then there's another new topic for digital rock physics, which is mixed wet conditions. And they have to be considered for the reservoir simulations because mixed wet conditions are created when the oil is pushed out of the reservoir during water flooding. And some pores can only be flooded with water at a really high external pressure due to the oil that is still on the surface. And thanks to Geodik's mixed wet surfaces, this flooding process can now be simulated, and also the corresponding relative permeability can be calculated. And we have many different approaches to do that in Geodik, and two of them, the deterministic approach and the stochastic approach, are verified by this publication you can see here on the bottom. Okay, then again, a hard cut to the next topic, filtration. And again, a bit of a look at the bigger picture. Imagine a world without any harmful air pollution. And of course, in the near future, this will not be possible without filters. And we can, with Geodik, can help you to develop those powerful filters to keep our air clean. So as the air pollution is a major threat in human life, and electrostatic charge filters that operate with a high filter efficiency at a really low pressure drop are a key to optimize air filtration processes. And what you can already do in Geodik, you can have electrostatic charge configurations for fibers, and you can have different particle charges. And we are working on adding dielectrophoresis and polarization. We are already implementing electrostatic decay functionalities, which significantly improve the quality of our simulation results. And of course, we are constantly validating the simulations by comparing the results to experimental data. Another mechanism to filter contaminants out of a medium is adsorption. So you can remove odors, gases, vapors, and various chemical contaminants. And you can use it for cabin air filters, for air purifiers, but also for water purification, for example. And in Geodik, there's a linear driving force model implemented, and you can calculate the breakthrough curve for this process. So here in this video, you can see the absorption in activated carbon. And as you can also see in this curve, at the beginning, all the contaminant is absorbed, and then time after time, the activated carbon gets saturated, and then once it's saturated, no contaminant can be absorbed anymore. And this behavior can be simulated into Geodik, so you know how to design your media for the absorption. And then one last really important topic in the filter simulation, which is the complete filter simulation. And in Geodik 2023, we focused on making flow and filtration simulations for complete filters much easier to use. So you can import CAD models, you can model cylindrical pleats, and directly set up the flow and filtration simulations. And in Geodik 2024, complete filter simulations are possible with multiple outlets where pressure or flow rate can be specified individually. And that allows to simulate, for example, cross-flow filtration, sectional backwash, and tubular membrane filters. And a tubular membrane filter is exactly what you can see in this video on the right side. So last but not least, there are a few topics that did not make it to their own slide, but are still very impressive and important. So we strongly improve the thickness estimation in MATIC. So if you have a planar material, such as a nonwoven, a weave, a paper, and so on, you can now choose this improved feature, and you get an even better thickness estimation for your material. And then something that we have, of course, always been doing is to constantly update the material database with constituent materials for your simulation. So in the material database, you already have materials that you can use to get a start, or even to create more accurate simulations of your material. And then one last topic I'm going to talk about is the detachment of contacts in ElastoDict. I'm sure quite a few of you have been waiting on this feature for a while now, so now we have it. And we have the Geodik contact detachment app. And in this app, you can not only simulate that two objects get into contact during compression, but the contact is also resolved again when you move them apart. So that's important, for example, for battery simulations, also in composites and nonwoven. So it will enhance your ElastoDict simulations whenever you have the need of this feature. So with this last feature, I will finish my presentation. I thank you very much for your attention. If you have any questions, feel free to ask them now or ask us later, or come to me and I will point you to the right expert. So thank you very much and enjoy the rest of our conference.